let's look at final exam question number 15, found on page 236 of Everyday Math Demystified 2nd edition. We have a round ball again, a sphere, just like we had in question number 14, and we increase its radius by a factor of 10. What happens to the volume? Well, if you'll remember the formula for the volume of a sphere, it equals 4/3 pi times r cubed, where r is the radius. So if this value here, 4/3 pi, is a constant because pi is a constant. So if we increase r by a factor of 10, we increase the volume V by a factor of 1,000. That's 10 times 10 times 10. That is choice D. I'd like to add a little bit of just something that's a note of interest that compares this question with the previous one, number 14. You'll remember that the area, let's use a different color just for fun. The surface area of a sphere like this equals 4 times pi times the square of the radius. So if we increase the radius by a factor of 10, we increase the surface area by a factor of 100, but the volume by a factor of 1,000. Now you can work out a number of problems of this sort, but in fact you'll find in every case that as the radius goes up, the ratio or proportion of the volume to the surface area goes up the same way. That is to say, the radius is proportional to the volume divided by the area. So if you double the radius, then you double the ratio of the volume to the surface area. That has a practical effect in real life. As you make a sphere of some particular material, say stone, larger and larger and larger. Let's just say that you have old limestone rocks that are perfectly spherical. If you double the radius, you also double the ratio of the volume to the surface area. So in effect, the object gets heavier in proportion to its surface area because there's more of it, more volume than area. It goes up faster and faster. So if you have a sphere that's, say, 1 centimeter in diameter, like a little stone on the side of a road, and you compare that with something that's 10 centimeters in diameter, that's about the size of a softball maybe, diameter being just twice the radius. If it's 10 times as great, that means that that softball-sized rock is going to be a lot more substantial in terms of its exposed surface area than the little stone is. And then if you make something 10 times bigger still, that would be a meter, like a boulder, a meter in diameter. Well, that would be 100 times the radius of the little rock, or 10,000 times the surface area, but 1,000,000 times the volume. So you'd have 100 times more of a substantial mass there in proportion to the surface area. Now that effect, imagine a hurricane comes along, and the wind in that hurricane is so strong that it picks gravel up off the side of the road and starts hurling it at stuff. That happens a lot in severe windstorms, tornadoes, and hurricanes. But if you have a boulder a meter in diameter, it's not too often you're going to find a wind that's going to even be able to roll that thing very far. much less pick it up and throw it. Although one might say, I don't know if a tornado can do that or not. You tell me. I doubt it. But you'll find that more substantial objects made of some solid substance that's of a constant material inside tends to stay put a lot better the bigger it gets. That's just a practical effect. There's other physical effects of this called scaling that you'll read about if you take any physics courses. But again, this question number 15, the correct answer is D. It will become 1,000 times more voluminous if we increase the radius by a factor of 10.